I'm from the TIB, which is the Technische Informationsbibliothek in Hannover, and we're part of the Leibniz Association and are the German National Library for Science and Technology. And since 2011, we have something which is called the Competence Center for Non-Textual Materials, which means that we focus on all kinds of materials which are no text. So like research data, research software, 3D objects, images, and also videos. And that's what I'm going to talk about today. After this great talk by Philip, I don't have to tell about science communication because I couldn't do it as good as Philip can because he's the expert in that. But let me start with a quote that science isn't finished until it's communicated. And I would even say that if you don't communicate, it's not even science. So if you just do some research at home, some private research, and you don't tell anyone, this is not what we would call science. So and it never has been. So some sort of communication is always part of science. And so the traditional way of communicating science is the communication first of all between scientists. So in a journal article or in books or what we do here on events, on conferences and giving talks, presenting posters. So that this is all kind of, you have to communicate what you're doing, otherwise you're, so it's an integral part of the scientific work. As we already have seen, that there is something like a gap between. We already discussed that in the last talk, that there's something like a gap whether you communicate with the experts of the field within your discipline, or if you communicate to the public. So, and if you look into the literature, you find lots of articles that describe these phenomena that most people think of these as two different arenas, where the scientist is either going to conferences, writing a paper, writing a very abstract way, they're describing the research, just describing what they're doing and what their results are for their peers, for the other experts in the field. But and then there's this other arena, which we had today, the comment that this is more like marketing, or we just go to the public and just present our results, and in a way where we think as Philip said it, the uneducated public can understand what we did. And this is, I think, one of the main problems that we have, these thinking that we have the experts on the one hand and the public on the other hand, and I don't have to explain to you because that's basically what this whole workshop is about. That you do talk with people that are not expert in your specific discipline, and that you have do interdisciplinary or multidisciplinary or transdisciplinary research, and that there's a whole world right in between. So there are people. So you cannot differentiate between who's an expert and who's a layperson, and that's and I think it's on the other hand, it's also worthwhile to talk to the experts in a way that everyone can understand. So to don't make things too complex just to appear somehow scientifically profound or something. And on the other hand, you shouldn't spare the public from the more complicated details. So because I think you have to tell how you got these, your results and what you're actually doing, and to communicate this. Because if you just say, okay, there's, I take the example Philip already had, there is something like a climate change, then this is just the same as if someone else would say there's no climate change. And for the non-scientists, you don't have any way to tell what's true. But if you say, okay, we did this and this is our data, and because of that we conclude that there is, then this is something completely different than just saying, I don't believe in climate change, right? And so I think it's important that you communicate in a way that at least aims that more or less everyone is able to understand. And a picture I find very instructive in that sense is taken from it started in the architecture, but it's now basically everywhere in different design principles. For example, if you design an app or something, which is this idea of universal design, where you have the idea that if you build a building and you always think that the broadest the audience or the broadest part of the community is able to use this building, or in this case the streets, and it's easy to understand even for blind people, for people in a wheelchair, for children, for old people, then it's good for all the people that are healthy in what we want to call healthy as well. So and there's a way to build this, and of course we had also the discussion with about the target group, and if you communicate, you always have to think about your target group which you want to reach, and this is not. Or this might seem contradictory to the thing that first of all you have to focus on your target group, but it's not. It's because universal design you can use, for example, if you build a library, and you can use if you build a public swimming pool, and if your target group are people that want to swim, you shouldn't build a library. But and if you want to, and if your target group is people that want to work in a quiet place and get information, you shouldn't build a swimming pool. So you should think about your target group, what you're doing, but you can apply these ideas of universal design to both the public library and the public swimming pool, and that's what I think what you can do in a similar way when you're communicating about science, that you, of course, you have to think about what is your target group, but you should make your presentation, your formats you're using as broadly understandable and comprehensible as possible. And yeah, so and this should be done as well in the world of scholarly communication as well as in the world of science communication, and there shouldn't be this gap. And what I'm going to talk about is now a bit more I focus just on this part, how videos may help in this. I'm not saying that videos solve the whole problem, but it's just I just want to give you some impressions what I experienced in the last couple of years working with videos, what people do, what examples they're using, what are good examples, what are easy to do examples, and what are common problems from a scientist's perspective as well as from an infrastructure perspective, like the library perspective. So, and I will start with the scholarly communication part and then go to the science communication part, although this is basically, as I said, you can also switch it around. It's more like taking the old conventions. And then I will focus a bit on the problems you see when people use these videos, and then show you what solutions we provide or we're working on in a moment. So let me start with another quote. So this is Professor George Whitesides. He's a Harvard professor chemist, very famous guy, has about 1,300 publications since the 1960s, and this is taken from a YouTube series about how to publish your research. It's a very good series. It's very worth to watch. It's called Publish Your Research 101, and he said, and he's talking about different types of how you what you can use in your publications. And one thing he's saying is, with videos you can now describe dynamic phenomena which are simply too complicated, too complex, too unusual, too full of information to do in words and to deep pictures. And just to give this a bit more content, I will give you an example. I worked together with a colleague from the Weierstrass Institute in Berlin. He's a mathematician and a physicist, and they published this paper here in 2016. They're working, you don't have to understand the details. I don't understand the details either. So it's just you have this the semiconductor with a P phase and an N phase. So this is the conductor, the diode, and they tested two different designs. The one is called the PIN and the other is the PPN. We don't care about the details. So, and you have this area in the middle with a hole in there, and they want to build quantum dots there, or ingest quantum dots there. And so what you have here, the two designs, and because it's of its symmetry, they cut it in half, and you just see the one side. And now they showed their results in this way. And as a physicist, you watch it and you look at this, and you, after some time, you understand what they're trying to say, tell to you, because this is the radial position, which is just this along this axis, and this is the time. So they show this just as some density that changes over time at this dotted line, right? And so the time goes from 0 to 300 picoseconds, and in the PPN, so the right one, something like this happens along this dotted line, and in the PIN, something like this happens along this dotted line. So at 0 seconds it looks like this, at 100 seconds it looks like this, 200 seconds everything is white. Okay, so and as you can see, this is already very difficult to explain, and it's probably even more difficult to understand what's happening here, because it's not intuitive that the dimension of time is here represented in space. So which is the normal way to put it, but you have the dimension time, which is the y-axis here, right? And so it's much more easy if you put the dimension time into time. And if you take a picture that has a dimension time, you have a video. That's all a video is, an image with a dimension time. And this is exactly the same you have here, just the z-axis. So this axis is added. You have here again the line. So what happens along this line is just what happens here, just that the time axis is the time here. And so now you don't have to explain very much. To understand fully, you should know what the colors mean and so on, but you get a feeling for okay, here something broad happens, and here it's much more concentrated and focused on one point. And so this is, and it, moreover, it contains lots of information you don't have in here, because here you only see the information what happens along this line, but here you have the whole information that what happens above and below that line, right? So in principle, it's much more easy for everyone to understand what's happening, and you have much more information. And in principle, this is this is nothing different from this. You just take, so they just do the same calculations. They just they just produced like 30 images, and this is basically just a flip book of 30 images. So it's not difficult to produce such a video, because it's not what we would call a video. And that's one example how you can use a video just to improve the understanding of such very abstract idea. And of course, you can do that for various different ways. So you have different visualizations of some simulations, or you can have just some observations, or here's an experiment and some time-lapse microscopy images. And so this whole information, this whole idea, you can also describe in words. You can just show a series of images, but to have the moving picture, you get the feeling for the dynamics, and you can just transport this idea not only to the specialist but also to the non-specialist. That's just very short, briefly for this. Then, of course, we have the conference recordings, which you already have seen the last couple of days. This is actually from, I think, from Monday, an image. And so this, again, is a typical way to communicate about science. And but it's in most, in 99% of these events, it's only for the experts, because only those would attend a scientific conference, and no one else knows what happens at a science conference. If I talk to my parents, they wouldn't know what happens on a science conference, but now you can just show them. So you normally don't have the what happens during the coffee break or in the evening, and probably you don't want to show that to your parents, but that's a different story. But just you open up science for a broader audience by just capturing this event, the talks, and just providing them to everyone who wants to see them. And what's happening over there, if you're interested, talk to Jens. If he has time, he will happily tell you. So he has this is just a screenshot of his program where he can do the live cutting. So it's all very very simple. At least the idea is that it's very simple, and that the video is more or less immediately ready when the talk is over. And so the first talk of this summer school is already online in the AV portal. The others will be in the next couple of days, and you can find them here on this link. And if you have some other conference and you want to record your conference or your event, just follow this link. If you drop the EN, then you have the German version. If you add the EN at the end, you have the English version, but you can also switch. There's a button in the right upper corner. And if you want to record your events, just give us a call. Or if you just think Jens is just a nice guy and you want to have him in the next conference as well, you can. And he really is a nice guy, so you can just book him, right? So and now, but that's basically what the main or what publications looked like 20 years ago. You basically had a text publication. You have a book, you have a journal article, or if there is an output from of a conference or a scientific event, you have something like conference proceedings, and then that's basically it. But what we have now is that the text publication, at least in some disciplines, loses in importance, and other the real research is done somewhere else. You have simulations, you have research data software, and all these are connected to a text publication. In general, you need some text to understand what's happening, and that's again from this from the series. Papers now are in a sense extended abstracts, and everything else is somewhere else. So you need these. This is another point. You need these informations to really fully understand what's been done. So if you don't see the data, if you don't have access to the software, you just have to trust these guys what they're writing in their paper, but you cannot reproduce it on your own. And so that's the one end of the story, and the other end is that you use good visualization like 3D objects or videos. So this is just a very rough idea of how you can use the videos for the scholarly communication part. And then let's come to the science communication. And Philip already showed some great formats, and this is more ideas that are more like the traditional conferences, so they're but for the broader audience. So there's the something like the TED Talks that probably most of you know, and some other popular formats which have like this 1.5 million views, which is much broader audience that you would normally have in a normal conference, right? And the other one here is a format I really like very much, which is the 3-minute thesis, and I think it's worth, especially as a PhD student, but in general for I think basically every scientist, it's worth to try to present your work in 3 minutes, just to reduce the main story. And even if you don't publish it, if you just do it for yourself, it's always beneficial if you just try, how would I present my research just in 3 minutes? And if you just do it for yourself, this is fine. You always have the story in mind, and you can build upon this all your presentations. You can, when you're on a party and someone asks you what you're doing, you can maybe reduce it to 90 seconds, but something like this. It helps in every situation. So in everyday life, it helps if you present it to the general public, if you present it to your grandma, if you present it on a conference, if you present a poster everywhere. And if you have the feeling that it's really good what you're doing, or you just have fun to do it, you can just produce a video and maybe put it on YouTube or whatever. And maybe even if it's very good, you can also use it as a video abstract for your paper or your publication. So I don't know if everyone's familiar with the idea of video abstracts. So video abstract is basically an abstract as a video, or a video used as an abstract. Pretty, that's, yeah. Yeah, it's simple as that. But yeah, so but it's a bit more. It's like so it should be short. As I said, maximum 3 minutes. If it has to be, maybe 5 minutes, but that should be a very maximum. So I think 90 seconds to 3 minutes is perfect. And you can most things you see are most video abstracts you see are something like this or this, just some interview or talking head video. But you can also, if you have what I showed earlier, if you have nice visualizations of your project, of your results, you can also use something like this and include it in your video, or have some mixture here where you have some visualizations and a talking person and a dog in this case, or you can do some stop motion videos. You just be creative. Whatever you want to do is fine. But if you want to use it as a science communication, it should be at least good enough. So it's always good to just do experiments, but it's not every video abstract is a good video abstract. There are lots of video abstracts that are no good video abstracts, and in that case, so I mean the whole idea is that you produce something which is sort of a teaser or a trailer, and if it's not if it's not fun to watch this video, there's no point, because no one will be looking at your video. And just to give you a bit better idea of what this could look like, these are my two favorite video abstracts, and you can. So the one is for publication in Cell, which is turning up gene expression to treat disease. And the other one is deconstructing climate misinformation to identify reasoning errors. So these were two very different types of video abstract, but I think the main idea is clear. So I think what also Philip said is very important, that it's just fun to watch. So it's just yeah, I mean, after watching this video, you really think you would like to read this paper and to know more about it. And the other important thing is that it's presented in a way that both the specialist gets the general idea out of it, and it's not and it's good for the specialist, but also more or less everyone would get at least the general idea of what those people are doing and why they are doing it, and why this is good or important research. And another side effect of this is, or I'm not sure if it's a side effect or what was happening there, I don't know. But at least in this case, both papers are pretty new, but they already have lots of views, citations, and there's also a study, which is, as far as I know, the only study that is about video abstracts and what they do to your research, and this study is already 4 years old, by Scott Spicer, and what he finds is that among the 25 or 100 most read articles, they had a significantly higher presence of video abstracts, although he's not saying, he's just stating that there is a correlation. He's not saying that there's a course. You have a question? Oh, okay. Yeah, so I think this would be pretty interesting to see whether this is just a fun project, and if it's just a fun project, it's still worth to do it, I think. Or if it already has some impact on your research or on the way your research is recepted by the public or the other scientists. And once again, I cite this White Sites from this series, where he says, I increasingly find that the stuff that we do that has probably the greatest impact in some metrics is done in video format, not in paper format. And I think he especially refers to something like TED Talks. So he's also given at least one TED Talk, I think even more, I'm not sure. And that's what he says, platforms like YouTube or something, they reach an audience that you cannot reach with a normal, in a normal traditional way of communicating science. And so just to wrap this part up, what videos can, or the main functions videos can do, and I'm not giving any advice on how to do this or what, I just say that it's worth to have a look at it and to be creative and find your own way, because this is very individual for each research project. But obviously you can use videos for visualization purposes. Of course, you can do it as for some sort of documentation with what we are doing here, but also if you do some experiments, if you do just some observations, you can document. This is a bit like what in the previous talk was with the science on the marketplace, right? With a half bowls on the marketplace. In that time, you would go to the marketplace and just do your experiment on the marketplace. And now you can just make a video of your experiment, put it to the digital marketplace, which is in the most cases YouTube for that reason. But I will come to the problems with this later on. Then, if you do it right, you can use it to reduce complexity or to better grasp, make the audience better, enable the audience to grasp the complexity of your research problem, and by that make the whole thing more comprehensible for everyone. And what I showed in the on the last slide, you can for yourself increase the visibility of your research. So there's so much research, and we also had this question of how do I get people to realize what I'm doing, and I think depending on what numbers you're looking at, 75 to 80% of today's internet traffic are video files, and so video is that format which is communicated in the on the internet, and I mean communication happens in the internet, and of course in other formats, but you know what I mean. Okay, so now let's come to the problems, and that's now the part where our work comes mainly in. What you find when you look at the ways the scientists normally use their videos, and if you ask a scientist, do you produce videos? Most people say no, we don't have videos. But in the end, if you talk a bit more to them, basically everyone has something like I showed in the beginning. We have 10 images where we could easily produce a video, or we have some simulation that moves, but we just don't publish it. We just take snapshots from of these and publish the snapshots, because the traditional format to publish is still text, and now it's not that much print anymore, but it's PDF, and PDF is basically the same as a printed paper, and you can do the presentation follows this idea of a text publication on a paper, and this is what you, in most cases, have. You produce a video, you have a simulation or whatever, and then because you want to show it in your publication, you take snapshots and publish it on in your paper. And in some cases, you provide the video as a supplemental material. But then, so who knows what archive is? So archive with a large X. 1, 2, 3. Okay, so the physicists obviously. So archive is a preprint server for preprints from it originated in the physics field, but now it's a bit broader. But it's also happening in other fields. So there's something like bioarchive or social archive or SOC archive, I don't know. And it's basically a place where you can upload your paper before it's published as a preprint. And so in physics, it's a really huge thing. There are more than 1 million papers available now. There's very important papers as well that only have been published there, and in some fields about 100% of the papers first get published on archive and only afterwards in a journal. And so it's not just some repository, but it's the place where you find, at least for some fields like high energy physics, you find basically everything there. And now if you have a look on how the authors treat their videos or what they do with their videos, I performed a search on archive just for papers that that state that they have videos in there. And this is just the search result, and I did not pick them. It's just search results 6 to 11, so it's just, and that was done in, I think, last year, 2017 or something. And if you see, the first one has videos, but they don't state where. And even if you open the article, you cannot find the videos. At least I couldn't. The next one has the videos embedded in PDF, so you need a special viewer to watch these videos. And this is okay now, but as a librarian, you'd think in terms of not just next year, but maybe at least next 10 years, ideally the next 100 years, and you don't know if you could, if you can watch these videos in 2 or 3 years. Then there's a YouTube link. There's some delivered in a source package. One is on a private web page, and one is in the other format section. So there are 6 publications, I think, and there are 6 different solutions. So there's that's far from a standard solution, and and the reason is basically that there is, except for YouTube, there's no platform where you can publish videos in a way that suits the needs of a scientist. And if you go through this, a lot of results you find is this, right? So you all know something like that. And we did something similar. So this was just some fun project I did with our subject librarian, physics subject librarian, and we wrote a small blog article about that. And then we had another survey among conference organizers where we saw that so don't take the numbers too serious. It were only 30 conference organizers, but what we see that there's no platform that most of them publish the videos on their own website, and you know how long a conference website lives. It's normally 2 or 3 months after the conference is over, and even if it lives longer, if you want to find conference recordings of some conference you know that took place, you simply don't know where to look for it. And even if you know where to look for it, you again find something like this. And these are just quotes from emails I had in the last years, and where I talked to conference organizers, and this is basically what happens. That there was this platform Blip TV, I don't know what that is, but obviously it stopped offering the service and the videos were down. And so it takes, we're now working for almost 2 years to get these videos back online, and it's very, very difficult because how do you contact all the people that attended this conference, who has the videos, and so on and so on. And the same is true for Vimeo. There were videos. This is an email from 2016, and the conference recordings from 2014 and 15 were already offline. And so that is a big problem. And so let me come to what we're doing. Just a brief show of the portal we're providing because of these problems. So this is the AV portal, the portal for videos that was developed by the TIB and the Hasso-Plattner Institute. And the TIB is, as I said, the National Library for Science and Technology, and these are the main subjects we're working on, although other subjects are also in there. And all videos get a DOI, so that is a persistent identifier where you should, or that is applied to the assigned to the digital object itself and not to the location where it's stored. And so if you use a DOI, you can cite the digital object, and at least if everything works out fine, you should always find the resource, or at least the metadata of that resource, and you should not get a dead link or link rot. About 95% of the videos are under an open access license, and basically everything except some medical stuff that you cannot show publicly is at least freely available. We also support ORCID for the authors, and we cooperate with different publishers where something like this happens, where you have this is the paper I showed you before, where you have the video and the paper both have a DOI, and you can cite the video in the paper and the paper in the metadata of the video, and so you have a persistent link via this DOI, and you have the whole story together, and you can also add, of course, research data, software, whatever. Then, moreover, we add this media fragment identifier to the DOI. You know that probably from YouTube, where you can put some timestamp behind the URL. But here we just add this to the DOI, which makes it persistent, not like the URL. And you can cite not only the starting point but also the end point. And so you can to cite the whole video, you can use the DOI to cite just, for example, here that's a video where you have 3 talks in one video, and if you just want to cite the second talk, you can just take the timestamp and just cite this talk. Or if you just want to use a quote, have fun on the conference, you just cite this 1 second where he says, have fun on the conference. And of course, you can do a similar thing with something like this, where you have the snapshots again, which were taken from a video in the paper. Each snapshot is for a single day, but in the video, the day takes like 4 to 5 seconds, and so you can just cite each day individually with this media fragment identifier. That's the persistent part, so no dead links. And the how to find part is that the videos, here it's only for the 6 subjects, the TAB, so the science and technology subjects, unfortunately, but there's a whole video analysis going through that. So before the video is uploaded, there's a scene recognition, so automatically the video is divided into parts, into sub-chapters by just the image analysis. You have a speech recognition, you have a text recognition, and an image recognition, so that you can search within the spoken text, within the text that is in the video, and you have and for some image concepts, so for example like a conference or a talk, and in the end you have a named entity recognition, so that whole process chain happens automatically, and you can you can search for these images. Just maybe I skip that because he's already standing there. And so maybe just very roughly, so this is the segment. You have the timestamp, you have the speech transcript with the timestamp. Here's the speech transcript. You can navigate through the transcript, and then the software takes out keywords like this software, and it comes up as a keyword for what you can look for. Okay, and with that, I'm done with my talk. Thank you very much. I could show you a live demo of the video of the portal if we have time, but we can do that, but we don't have to.
Thank you very much. Yeah, we are running a bit out of time. Okay. So because we have this exercise with Philip afterwards, but we can take a couple of more minutes for him.
For me, 12 is perfectly fine. When the lunch break is at 12:30, so half an hour is enough.
Okay. So then we first start with some urgent questions, and then we see how long it takes to answer them, and then we have some more opportunities.
I wanted to ask you, because that thought crossed my mind already a few times, what do you think of the use of wikis as a publication format, because it allows you to embed videos, pictures, whatever, and at the same time also link all the different research, just as a potential format as opposed to the PDFs that we usually use?
So it's a good question. So colleagues of mine, they worked in a very similar direction. So there's this lab called Open Science Lab in in the TIB, and they did something which is called Handbuch.io, the platform, which is based on a wiki page or on a wiki infrastructure, and the infrastructure basically works as for collaborative writing. So they used it for something like book sprints, where people in just 3 days write a handbook on something, and then you can also publish it. I mean, the problem with wikis is that you need to that you have a living document, and you if you want to cite them, you have to have something like versioning and a stable version. But they also solve that, so you can basically. I think they also have DOIs for different versions, so you can take a snapshot now, say, okay, this is now my my version 101, and then like this. So I think that's a very, at least if you're a highly collaborative working environment, then it's a very good way to work in that place, because you also have the possibility to invite others to collaborate, and to for others to see the whole process of writing and publishing at the same time. I don't think it's perfect for every use case, but I think it's a very good way for some, at least for some ways. Yes.
Well, thank you. It was very good. It just came across my mind that what is the real possibilities of having a full-scale peer-reviewed scientific video instead of peer-reviewed scientific paper in next 5 years?
Yeah, there are these ideas of video journals or peer-reviewed video journals, and there was one I'm aware of, Jove. But as far as I know, they changed their business model because I think maybe it's also because they you had to subscribe to their platform, and maybe if they would have done it open access, it might have done. But I don't know any details there. But I think that whole just a video journal, or where the whole presentation is just done in video format, I personally don't think that will happen. But there are people that believe that. I don't. So because I think that still to think about a topic, at least I have to read it. So I still need the text, or I need a text to think about the ideas, to see what happens, or to because you can read in your own speed. And of course you can do you can manipulate the speed of the video, but it's something different than reading. And I think it's a good addition to text, but I don't think that it will substitute text. Although, and the question of peer review is something where, again, the question is how good is peer review also for a paper, and how can we improve? So I think the question is more, how can we improve the quality check of peer review in general? So like ideas of, for example, open peer review, just add some comment, and you can the possibility to comment or to discuss right online, and I think that's much more efficient than peer review is in many cases. And I don't think that peer review is
So thanks. I have like 2 very basic questions. So I just Googled how to get in DOI. I didn't get what I found. Maybe you could just shortly explain how to do that for videos or anything. And then I was wondering whether there's some kind of differentiation between like animated crafts or illustrations and videos, like for the tagging or anything, because intuitively videos would imply a storyline for me. And some of these were like more like animations than videos. And then there's the comment I wanted to make, like especially for abstract videos, that could also challenge how scientists are viewed in society, because people might then see that scientists are not only older white male persons. So it could also be a nice push for diversity.
Yeah. Okay, so the first question, you cannot get a DOI on your own. So DOI is something you have as an institution, or so it started from publishers. The one big DOI assigning community, whatever, is Crossref. That's basically a community of publishers, and they started to give DOIs for papers. And the other thing, and then that started at the TIB and other libraries that started to give DOIs for research data, and from this the initiative DataSite emerged, and that's where we, for example, get the DOIs from. But you have to register as an institution, and you have to. That's the only thing, or the only way it really works, because as this institution, you guarantee that you will keep your metadata updated. Because if the object moves to another server, you have to update the URL in the metadata, and so that the DOI still leads to the same landing page at least, or and ideally to the object. Yeah, but there are many repositories that so you can, if you have a video, you can just upload it at our place. It's free, and you have a DOI for your video. Then there's for data there are platforms like Zenodo or Figshare, where you can basically upload everything, and they also have DOIs now. Yeah, and the second question was again?
Like differentiation between just any animated stuff and videos, whether in the discourse that you're having, whether there's such a differentiation?
We haven't looked on that this far. So right now, anything that moves is and is a video. Yeah, but that's something we want to look at. Yes.
Okay, if there are no further questions so far, you may have 2 minutes left for that, but then we'll skip that.
Probably, yes.
And thanks a lot again